In this video lecture, I will solve DFA construction problem. So the problem is draw a DFA to accept string of zeros and ones ending with the string 011. So whenever we have to construct a DFA, what all step we have to follow? So the first step is whatever language is given to us, we need to write all the valid string of that language. So here it should contain string of zeros and ones. So one thing is clear, my input alphabet sigma is 0 and 1, and language is what it should have all the string of zeros and ones ending with string 011. So ending with string 011 means 011 is also fine, and then it can start with 0 and then end with 011, or it can start with 1 end with 011, right? So here it starts with nothing and end with 011. So and here it start with 0 end with 011, start with 1 end with 011, or I can say any number of 0 and then end with 011, or any number of 1 and then end with 011, or any combination of 0 and 1 ending we should have 011, or it can be 1010 and 011 and so on. So these are all possible valid string of this language. Now this is the first step. Whatever language is given to us, we need to first write all the valid string like this, and then we have to pick up the minimum length string and we need to draw the DFA for that. So here the minimum length string, because it always end with 011. So at least 011 will always be there, and the length is what here, the length of 011 is 3. So next we need to construct a DFA for 011. So why we construct DFA for minimum length string? It is just to decide the number of states in DFA, because the problem is given to us how we are going to decide how many states we require. So it is easy, if we pick up the minimum length string, that's how we can decide the number of states in DFA. So to accept string of length 3, at least I need 4 states, right? So 0 and then 1 and 1, and because this is a valid string, it has to be accepted. So this Q3 should be a final state, and this is start state. So this is not the complete DFA. Now the next step is what? After this, we need to see the transition from each state for all possible input. That means I have total 4 states here, Q0, Q1, Q2 and Q3. So from Q0 we need to show the transition for 0 and 1. From Q1 we need to show the transition for 0 and 1 both. From Q2 we need to show the transition for 0, 1, and from Q3 also we need to show the transition from 0, 1. So now how will we decide? So because this is hit and trial only, and we need to analyze, and then whatever transition we are going to write now, we have to see whether it is accepting all the DFA, it is accepting all the valid string, because whatever DFA we are going to construct, it should accept all the valid string of the language, and it should not accept even a single invalid string. That's how we have to design our DFA. So now we'll start from the start state Q0. So Q0, the transition for input 0 is shown. Now we have to see the transition for input 1. So now there are 1, 2, 3. So total 4 possibility, because there are 4 states. So one possibility is I can put self loop, or another possibility is I can put self loop here, or I can send 1 to this, or I can show the transition from Q0 to Q2 for input 1, or I can show transition from Q0 to Q3 for input 1, right? So these are the 4 possibility. So now we will check one by one. What if I consider this one? So Q0 to Q1, if I take this transition for input 1, so what will happen? I start from Q0, 1 and then 1, 1. So what is happening? 1, 1, 1 is accepted by the machine. But 1, 1, 1, is it valid string? No, because it has to end with 0, 1, 1. So here it is not ending with 0, 1, 1. So this is invalid string. So that means this transition is not correct. Now we'll see this one. If I take this one, what happens? Machine will be in start state Q0, and then input 1 is given. It comes here and then 1. So 1, 1 is accepted. This is also invalid. So that means this also is not correct. Now we'll see this one. So this is machine will be in state Q0, and then 1 is given and it is going to final state. So 1 is also accepted. So this is also not valid one. So this also can't be taken. Now if I put self loop here, what happens? Any number of 1 and then 0, 1, 1 is accepted. So that is our valid string, basically any number of 1 and 0, 1, 1. Or I don't take this one because it is a self loop. So when I say self loop, the meaning is it is 1 star. So that means epsilon 1, 2, 1, 3, 1 or any number of 1. So that means epsilon means 0, 1, 1 is accepted. Then single 1, 0, 1, 1 or any number of 1 and followed by 0, 1, 1 is accepted. So this is correct. These three are not correct. So we cannot take these transitions. So that's how we have to first try and see whether we can consider that transition or not by just seeing if I consider that transition, so what happens, whether it is accepting valid string or invalid string. If I don't consider that, what happens? So all that we have to check. Okay, now from q0 both the transition 0 and 1 shown. Now from q1 also same way we will check. So from q1 1 is shown, we have to show the transition for input 0. So again we have four possibility. Either I can put self loop, or I can send this 0 here, or I can take this transition from q0 to q3, or I can have this transition, right? So now if I send this 0 here, what happens? 0, 0, 1. So 0, 0, 1 is accepted. That is wrong. So that means this is not possible. Now if I take this one, what happens? 0, 0 is also accepted. So this is also wrong. That means this is also not correct. If I consider this transition, what happens? 0, 0, 1. So 0, 0, 1 is basically a valid string, but here it is ending at non-final state. So whenever a string is valid, it has to end at final state. So this is a valid string, but as per our DFA, it is not accepted by the machine. So whenever we are constructing a finite automata, always remember whatever string we are taking, the valid string, the machine should always accept all the valid string. If it is not accepting a single valid string also, the DFA is not correct. And if it is accepting any one invalid string also, it is not correct. So it has to accept all the valid string and it should not accept even a single invalid string. So that means this is also wrong. So now if I put self loop, what happens? 1, 0 and then any number of 0 and anyway 1, 1. It will always end with 0, 1, 1. So we can say any number of 1, 0, 0, 0, any number of 0, but anyway 1, 1 will be there. So end with 0, 1, 1. Or I can say 0, it start from q0. I can say 0 and then any number of 0 and then 1, 1. So this is also fine. So that means this is correct. These we can't consider, right? Now from q1 we have shown for 0 and 1. So let us draw it again here. Okay, so q0, 1 is this, 0 it is going to q1 and then 0 self loop, 1 it is going to q2 and then 1 it is going to state q3, right? So from q0 0 1 is shown, from q1 0 and 1 is shown. Same way for q2 1 is shown, 0 we will see what to do. So now if I put self loop here, there are again four possibility: self loop or 0, or this 0 can go here, or this 0 can go here. So what happens if I put self loop? 0, 1, 0, 1. 0, 1, 0, 1 is also accepted. That is because it is not ending with 0, 1, 1. So it is wrong. That means this self loop is not correct. If I put 0 here, what happens? 0, 1, 0 is also accepted. 0, 1, 0 is accepted. So it is not ending with 0, 1, 1. This is also wrong. So this also cannot be taken. Now if I take this 0 here, what happens? 0, 1, 0, 1, 1. So 0, 1, 0, 1 and then 0 and then any number of 1. So anyway this 0, 1, 1 is also it is ending with 0, 1, 1. So basically it is a valid string, but it is we are at non-final state. So if it is a valid one, we have to be at final state. So this is a valid string, but it is not accepted by this. So this is also wrong. Now this is the only choice left. We'll see 0, any number of 0 and then 1 and then 0 1 1. So this is fine because anyway after once we encounter 0 immediately we are going to this state and then 1 1. So it will always end with 0 1 1. So this one is correct. This is not correct. So we will remove these unwanted transitions. Okay. So here now from Q2 also we have shown all the possible transition. Now this is fine. Okay. Now only Q3 is left. Same way from Q3 also we will check. So from Q3 input 0. What if I put self loop here? If I put self loop here, what happens? 0 1 1 then any number of 0. So any even 0 1 1 0, this is also invalid string because it has to end with 0 1 1. So self loop anyway this is wrong. If I send this 0 here, what happens? 0 1 1 0 1. So 0 1 0 1 1 0 1 is accepted. It is not ending with 0 1 1. So this is also wrong. If I send this 0, if I send this 0 here and then what happens? 0 1 1, and anyway when 0 comes we are going to this and 1 1. So this is fine. Same way for 1 also, if I put 1 here self loop, what happens? 0 1 1 1. So 0 1 1 1 end with 1 1. This is wrong. So self loop of 1, it is not possible. If I send 1 here, what happens? 0 1 1 1 1. So it will end with all 1 1 1 only. So that also is wrong. If I send this 1 here, what happens? 0 1 1 1 1 1. Again it will end with 3 1. So that is wrong. So if I send this 1 here, what happens? 0 1 1 1 and then 0 1 1. So always anyway this path we are going to follow. And if I say, see, 0 1 1 1 1, so it is not ending with 0 1 1. So this is correct. So now let us draw the neat DFA. So we have Q naught, that is start state 1 and then 0, then Q naught self loop of 0 and then 1 Q2 and then again 1. Q3 is a final state and then this 0 is going to this, and similarly this 0 is going to this, and 1 is going to this. Okay, so 0 1 0 1. Here also we have shown 1 0. So this is 0 and 1, and here 0 1. So this is the complete DFA. From each chart we have shown the transition for both the possible inputs 0 and 1. So this is the final DFA. Hope you have understood the concept. Thank you for watching.